Picture a single online order. The moment a customer clicks buy, a lot has to happen. Charge the card, send a confirmation email, update inventory, notify shipping, log it for analytics. If your app tries to do all of that in one breath, one slow step can break the whole order. The fix is to let your services talk through messages instead of calling each other directly. AWS gives you 3 tools for this: SQS, SNS, and EventBridge, and almost everyone mixes them up. By the end of this video, you'll know exactly which one to reach for, with pictures, using that one order as our example the whole way through. First, why bother decoupling at all? Imagine the order service calling the email service directly. If the email service is down, or just slow, the order fails too, they're chained together. Now put a message in between. The order service simply drops a message and moves on. The email service picks it up when it's ready. If email is down for a minute, the messages just wait, nothing is lost, and the order still succeeds. That's decoupling. Your services stop depending on each other being up at the exact same instant. It's the single biggest reason these 3 services exist. They are the buffers and the wiring between your parts. Here's the one mental model that makes all 3 click. It comes down to how a message gets delivered. SQS is a queue you pull from, messages wait in line, and your worker asks, "Anything for me?" and pulls them down when it's ready. SNS PUSHES, the moment something happens, it shoves a copy out to everyone listening. And EventBridge ROUTES, it inspects each event and sends it only to the targets whose rules match: pull, push, route. Keep those 3 verbs in your head and you already understand the heart of this whole topic. Let's start with SQS, the simple queue service. Think of it as a holding line, like order tickets clipped up in a busy kitchen. Your producer, the order service, drops messages in as fast as it likes. Your consumer, a worker, takes them out one at a time and processes them at its own pace. If 1,000 orders arrive in a sudden burst, they don't crash your worker, they just queue up and wait their turn. That's called back pressure, and it's SQS's superpower. It absorbs spikes so a slow step never overwhelms the rest of your system. One queue, one line, many patiently waiting messages. But a queue has to be reliable, and that's where 2 settings matter. First, long polling. Instead of your worker constantly hammering the queue asking, anything yet, it waits quietly until a message actually shows up, cheaper and calmer. Second, and this is the classic trap, the visibility timeout. When a worker grabs a message, SQS hides it for a set time so no one else grabs the same one. But if your worker takes longer than that timeout to finish, SQS assumes it failed and hands the SAMI message to another worker. Now it runs twice. The rule to remember: always set your visibility timeout longer than your job actually time out. What about a message that just won't process? Bad data, a bug, something that fails every single time. Without a plan, it gets retried forever and clogs your queue. The answer is a dead letter queue, or DLQ. You tell SQS if a message fails, say 5 times, stop retrying and move it aside into this separate queue. Your main line keeps flowing, and that poison message sits safely in the DLQ, where you can inspect it, fix the cause, and then redrive it, replay it back into the main queue to try again. A DLQ is your safety net for the messages that go wrong. SQS comes in 2 flavors, and the difference is really about honesty over guarantees. Standard queues are fast and cheap, but they are at least once, order isn't guaranteed, and you can occasionally get the same message delivered twice. FIFO queues, first in, first out, keep strict order and remove duplicates within a 5-minute window in exchange for lower throughput and a slightly higher cost. People love to call FIFO exactly, once, but be careful, that means exactly. Once within that dedup window, not a magic guarantee forever. If order truly matters, like steps in a workflow, use FIFO. If it doesn't, standard is usually the right, cheaper default. This leads to the rule almost no tutorial teaches, and it bites every beginner. Because standard SQS and SNS can deliver the same message more than once, your consumer must be able to handle a duplicate safely. That property is called being idempotent. Running the same message twice has the exact same effect as running it once. Picture the difference. A careless worker charges the customer's card again on the duplicate, a disaster. An idempotent worker checks, have I already processed order 123, and quietly skips it. Design every consumer this way and duplicates become harmless instead of expensive. Now SNS, the simple notification service, the push side. Where a queue feeds one waiting worker, SNS takes a single message and fans it out to many subscribers at once. You publish to a topic, and everyone subscribed to that topic instantly gets their own copy, other services, email, text message, or a Lambda function. And with message filtering, each subscriber can say, only send me the events I care about, for example, only orders over $100. One publish, many receivers deliver the instant it happens. That is SNS. Here's the part the comparison videos miss. SNS and SQS are usually not a versus. They're a team. The classic combination is called fan-out. Our order service publishes one order placed message to an SNS topic. Subscribed to that topic are several SQS queues, one for email, one for inventory, one for analytics. SNS instantly pushes a copy into each queue, and each team's worker pulls from its own queue at its own pace. You get SNS's instant fan out and SQS's buffering and reliability working together. So when someone asks SNS or SQS, the real answer is very often both. Third is EventBridge, the router, and the smartest of the three. It's an event bus, your services, and even outside SaaS apps drop events onto it, and you write rules that say, when an event looks like this, send it to that target. So one order-placed event could route to a Lambda, while a refund-requested event routes somewhere else entirely, all decided by the event's content automatically. EventBridge also speaks natively to over 100 AWS services, and partner apps can keep a schema registry so you always know each event's shape, and can even archive and replay past events. When you need smart routing and filtering across many sources, EventBridge is the tool. Two modern EventBridge features the older tutorials completely miss. First, EventBridge Pipes, a clean point-to-point connector that takes one source, say an SQS queue or a database stream, optionally filters and transforms each event, and delivers it to one target with no glue code in between. Second, EventBridge Scheduler, a single place to run things on a schedule, cron-style jobs, or one-time future events like, send this reminder in 3 days. This replaces the old CloudWatch events approach you'll still see in dated guides, pipes for wiring things together, scheduler for timing. So how do you actually choose? Here's the simple decision tree. Do you need a durable buffer so a slow consumer can catch up, or strict ordering? Use SQS. Do you need to send the same event to many receivers at once? Use SNS, and usually SNS plus SQS in that fan-out pattern. Do you need smart routing, sending events to different places based on their content, pulling in other AWS or SaaS services, or scheduling? Use EventBridge. Buffer, broadcast, or route, match the verb to your need, and the choice makes itself. A quick, honest word on cost, because the tutorials just say cheap. You pay SQS per request, SNS per message published plus each delivery, and EventBridge per event put on the bus. They are all inexpensive at small scale, fractions of a dollar per million, but the shape differs. SNS fan-out multiplies deliveries, and FIFO costs a bit more than standard. The practical takeaway, for very high simple throughput, standard SQS is usually cheapest. EventBridge costs a little more per event, but it buys you routing you would otherwise build by hand. Always estimate at your volume, not at a single message. Let's put it all together with our order. A customer clicks buy. The order service sends one order-placed event to EventBridge, which routes it. Valid orders go forward while test events are filtered out. It lands on an SNS topic that fans out to 3 SQS queues, payment, email, and analytics. Each worker pulls from its own queue, and every worker is idempotent, so a duplicate never double charges anyone. Anything that keeps failing drops into a dead letter queue for a human to check. One order, cleanly handled by all 3 services, routing, broadcast, and buffering, each doing the one job it's best at. Let's lock it in. SQS is a queue you pull from, a durable buffer that absorbs spikes. SNS pushes one message out to many subscribers at once. EventBridge routes events to the right targets based on their content. They are not rivals, the fan-out pattern, and our order example use all 3 together. And remember the gotchas, the other videos skip, expect duplicates, and stay idempotent. Set your visibility timeout right, and always add a dead letter queue. If this finally made AWS messaging make sense, subscribe to VionCloud. We make the scary parts of AWS simple, with pictures, and I'll see you in the next one.